definition of a graph, or graph definition. The graph of an equation in two variables is a set of points that corresponds to all solutions of the equation. We may not necessarily be able to put all of them on the graph, but we can imply all of them. Example, plot the equation y equals 2x minus 2. Well, suggestion, first make a table. One way to graph. And thus 4, 3 satisfy the equation. So the equation y equals 2x minus 2. And let's realize that the slope, or the end value, is 2. And that the y-intercept, or the v-value, is negative 2. Okay, so let's make a quick table. From the table, do remember, x always comes first, then followed by the y. This order will never change. Okay, what could we select for x values? That's entirely up to you. Flip a coin, pick them out of a hat, but for your sake, make it easy, right? Make it easy for yourself. Let's pick some basic numbers. So y equals 2 times where the x is, we're going to replace it with a value that we pick. And then minus the 2. So what x value could we pick? How about we pick a negative 1, just for reference in this case. Once again, otherwise you can pick whatever values you need or want. In many cases, only 2 are required, but the more x values you pick, the better of a graph you get. So let's substitute the negative 1 in for x. So negative 1 enter. Y equals 2 times negative 1. Well, that gives us negative 2. Negative 2 minus 2 will give us negative 4. So when x is negative 1, y gives us negative 4. Input negative 1, output negative 4. Okay, so let's pick another value. Agreed? What x value could we pick in this case? Well, how about 0? Make your life easy, right? So plugging in 0 for our equation from before, 2 times 0 in this case. So y equals 2 times 0 minus 2. 2 times 0 is 0. 0 minus 2, well, that's just negative 2, agreed? So negative 2 is our output. Input of 0, output gave us negative 2. Let's try the next one then. Y equals 2 times, what could we select in this case? Hey, you may have guessed. 1. Make it easy, right? 2 times 1, 2. 2 minus 2, 0. Hey, that came out fairly easy, right? So there it is. We now have a table that we can graph. So let's make a quick sketch, quick graph. Do remember, hence sketches are totally fine. So x-axis label and y-axis label, we should try to remember those. And our first dot, when we have negative 1 for x and negative 4 for y. There's our first dot. Second dot, 0 and negative 2. Hey, it has a 0 on there, right? So therefore it has our y-intercept value of negative 2. It's our y-intercept. Crosses the y-axis, agreed? And look at that. The next one's also an intercept. It's an x-intercept. And that's because y in this case is the one that becomes 0. So 1 comes 0. It's our next dot. And now we can trace a line through those 3 dots. Keep in mind, choose the very minimum, but 3 makes it a more straight line. I often draw crooked lines because I only use 2 dots, and then again, my arm seems to go to a totally different direction once I try drawing a straight line by hand. But luckily, it makes it straight here with a computer. So there we go, straight line. Line that goes through all 3 points. And now, let's remember the question. Is 4, 3 a solution? And remember, the x value is a 4, the y value is a 3. Agreed? This will never change. Always the x first, followed by the y. So let's try plotting 4, 3 on our graph here. So plotting, 4, 3, does that look right to you? Is that where 4, 3 is? Yeah, that's the location of 4, 3. Does it land on our graph in this case? No, it doesn't land on our graph. So would you say 4, 3 is a solution of this equation? You got it. It's definitely not a solution in this case. 4, 3 is not a solution in this case. It does not land on our graph. Okay, so there's an example. Do remember, the fact that we have arrows on the top and bottom of our graph implies that it keeps going forever, to the left and down, and to the right and up. So for this case, once again, 4, 3, not a solution. It didn't land on our graph.